Now I'm talking about attempts to interpret data from the river using AI. Protecting the birds out on the river is really quite a multidisciplinary thing, I think. You've really got to have some understanding of quite a few things. Only the first two of these are in my background at all. The rest I'm just a complete total amateur in. So how can I work in these fields and understand what's going on without the proper background? I could do a heap of literature research, talk to a lot of people, or try AI. So here's a few rapid fire snippets of AI case studies. I know I always have too much and go too fast, but it is on a handout you can get. So the first thing I gave AI was this map here, which has got wrybill nests and their territories as defined from multiple observations of the birds. And I just told that to the AI and I said, can you provide any insights? And to my surprise, it gave a really detailed analysis of nest locations and territories and comparisons with other species and all sorts of things, much more than I expected. So then I went to the BW area. We've got the same thing. We've got nests and territories. And it did an even more impressive analysis of what was going on, why the nests were where they were, why the territories were there, and such things as suggestions that the nests might be protected from northwest wind, which I don't think is actually right, but it was nice to see. But what really interested me was what is in red. About older birds often anchoring the first territories. At this stage, I didn't know anything about BW. And it's absolutely true for this area. And later arrivals pack around them. Density increases until territories reach minimum viable size. And the river may actually show the expansion phase of colonisation. So then I went back to that previous area to see if there was any equivalent to BW. And the obvious one is BR, simply because the name sounds the same. And it's right in the middle of the river. To see if they're old birds too. You can't tell with BR herself, the female who was banded on our river in 2022. But her mate was banded in 2014. He's got a metal band you can read with a good lens on your camera. So he's an older bird. We don't know how old, but he's, by our standards here, he's probably quite an old bird. He gets there fairly early. Last season, he was there at least 26 days before starting nesting. And what's been happening is they've been holding down a central spot in the river, just sort of moving north and south while other birds are finding places to nest around them. They could be a really important bird in this part of the river. And I'm going to get onto this right now or very soon. So that business about the river actually showing expansion phase of colonisation, that was just based on those two maps showing quite dense nesting. Well, it's absolutely true. The graph shows two measures of wrybill population, the nests and half the annual count, which, given the work we do, that's an incredibly good correlation, I think. And the map below shows that with those arrows, we're starting to see nests or evidence of nesting in places we didn't used to. They're increasing and spreading out along the river. Just going back to BW again and reminding what he is or was, how long he's been there. He's actually produced a whole lot of chicks, and he's very old. And I asked how important has BW been to the wrybill population on the river, and it replied, it's a super breeder, and that we're currently looking at a timeline where BW could have 5 to 7 generations of descendants using the river. Perhaps 30 to 50% more of the current 58 adults could be related to him. So there's a real big assumption in this, and that is that his chicks return to the river. But otherwise, even if they go somewhere else, he's providing some pretty bloody good genetics. So this stuff is, well, I went back to it and asked it for some clarification, how it worked out these numbers, and it gave me what I thought was a really pretty good explanation. This is something for somebody else to have a look at and see if it makes sense, but it certainly does to some extent to me. Next one I'll go through fairly quickly. This is my attempt at illustrating how you can bugger up braided rivers from management. I'm not going to look at that in detail. It looks sort of moderately complicated, but I think it's not nearly complicated enough. I asked AI, what major things am I missing? And it didn't get it at first, but after another prompt, it got it. That you've got self-reinforcing feedback loops there, which are making things a whole lot worse. I gave three examples of that. This is the first one and the more obvious one. If you make a river narrower, it goes fast, it gets straighter and cuts down and gets narrower, and the process continues. So I think fixing a neglected river is not as easy as just removing trees and making it wider. The river has been changed to a different sort of river, and it will take a very long time unless you're going to do a whole lot of excavation for it to return to what it was. Then on to black-fronted terns. This is one of those 6 colonies which Emily was monitoring and trapping and everything on last season. I gave AI quite a few illustrations like this and graphs and things for it to look at, and got a lot of really good, interesting replies, but I'm really only going to show the final conclusion on it. So, yeah, we have a lot of colonies, which sounds good, but it isn't, because that is because the birds are re-nesting. This was by far the biggest colony that we ever had at 93 nests, which is not good, that's bad, because they were re-nesting from other places. And this place, the 93 nests, produced 35 of them hatched, and there were 10 fledglings, which is not really very good at all. So what we got on this map is traps, trail cameras, nests, and outcomes for every nest. And we actually think that cats were probably the big, so hedgehogs on the south side where they couldn't cross the river, but there were cats caught out there, and probably at least, I think we saw 2 more that weren't caught. There may have been more than that, and I think they went around cleaning up the chicks. So this is good hard work. Well, the obvious thing we've got to do is triple the trap numbers, but that is easier said than done. I'll flick past that because I keep running out of time. But this is that graph again of fledgling productivity, the orange line, which collapsed in about 2018. And the bar chart is basically the reason for it, or the initial reason. We had a rat boom. It's not the ship rats that are the problem, it's the Norway rats. And more recently, cats have taken over as the main problem, because this graph doesn't really show it, but both the ship rats and the Norways seem to be disappearing. So the ribel are not nearly as badly affected as the black-fronted tern are, but we've got a really bad situation here, I think. Last season, it was 15% fledgling productivity per nest, but I think it's about 36% per pair, which, I don't know, might be half of what we need, despite really quite a lot of good work. So just a summary from this one. I came across these concepts, which are totally out of my field, but quite interesting concepts: sources, sinks, and ecological traps. So I asked ChatGPT actually how we would fit in with those concepts, and it gave what looked to me to be a very good answer to that we're edging towards, well, we're actually are a sink and we are an ecological trap, and we have to somehow get out of that. So I was quite impressed by that summary of everything that I'd given it. This second last slide shows two things. The line graphs are Norway and ship rat catch over the years, and there has been a real boom in numbers. We used to some years catch no rats at all, and it got to the stage where rats were by far our biggest catch in our traps. I've really been puzzling what the hell might have caused that. But at about the same time that we had the rat boom, we had this seedling, willow and poplar boom. So I'm wondering whether there could possibly be a link between those two things. And the last seeding season, there was far fewer seedlings, far less seedlings around than this season. I gave this suggestion to 3 AI models, and they all thought that, yes, there could be a link, a sort of masked effect. And I have no idea whether there's any truth in this, but I think it's worth looking to. It's sort of really interesting that perhaps you can, well, it's like a beach mast. You get a rat boom, and that affects the forest birds. So, final slide. People are supposed to bloody laugh at that. Thank you. Yeah, my summary is, if I was still working as a mineral exploration geologist, I would be giving AI all my geological, geochemical and geophysical process data, and I would be expecting it would come up with things that I don't understand. So for things that are totally out of my field, I will most certainly keep doing it. And I think that it is really quite essential to use it. So maybe everybody here is already doing it. I know some aren't, but it is really bloody useful. So we have a PhD ornithology student starting next month who will help us with a bit of the understanding of that aspect. But till then, yeah, we'll be using AI.